Okay, we are live here. Hello. Let me set the title of this, and then I will switch the screen over real quick. It's been a while. I think I haven't streamed in like what, a week, a little longer. Let's just grab category software and game development, and then we can just go to restream. And I think we're good. Yeah, we're good. Whoops, that's the puffer. There. Hey, Jess. So, what has gone on in the last week? So, first of all, we had a sort of rush order client job, where some of the work for that I wasn't able to stream, some of that was private. And then thereafter, I don't know. I think that thereafter there was a bunch of fiddly experimental work and just a bunch of like really annoying refactor stuff that wasn't particularly interesting, and where streaming would not really bring anything. Things are relatively stable now. I have a little bit of time this week to be working on the core code base. So I'm going to go over very quickly what we have from this. Here we have a experimental branch of Puffer with everything in CUDA and C. It's quite a mess. This is already after a few phases of refactoring. It's quite a mess. It has nearly 3 times as many files as there should be. A few thousand lines more code than there should be. But this is including the protein port, this includes Constellation, this includes the PufferNet CPU version, this includes all the new self-play stuff, and it's under 14k lines. So what I'd like to basically do is figure out how to get this cleaned up, fewer files, fewer things jumping all over the place, fewer lines. We'll want a couple of tests for this, not very many, just a couple overall things with it. And yeah, we'll go from there. I think just the historical self-play is mostly stable, but that it doesn't guarantee that you're going to generalize well to held out policies. Okay, so let's think what we do next. I just pulled in the changes from the latest protein PR. I haven't actually looked at the protein stuff because I think it was very heavily AI gen. Though with a lot of manual cleanup. I'm going to see if we can get a couple files merged first before I really get into too much detail. Do we still use Puffer Train or do we use Puffer Sweep? Puffer Train is still the correct thing for individual runs. Excuse me. This is also, Jess, I'm not saying that it's stable on this branch, right? This is a new branch. We're testing stuff here. Of course, we're not going to just take this thing's advice. Okay, that's a lot of indirection and jankiness, isn't it? Ugh, it's a lot of stuff. Yeah, okay. There's definitely stuff to clean up in here. I would say the code for this does not look great to me at all. So I think I'm not going to care too much about messing things up because it's already not amazing. Okay, merge. Instead, first GP. Files. Protein. Alright, but yeah. So Glitzy on the Discord submitted this, and already to his credit cleaned up like 700 lines of it. So obviously we can save a lot more. So let's just remove 2 files real quick and see if this gets us a few lines. What I'm doing here for reference, oh, I should also update this title. And cernitation. I don't know. Mucking through sewage. That sounds about right. Well, it's very annoying, like, I don't think people realize how much that, like, this shitty stuff makes you dependent on it. It's not like, oh, the AI gens some code, now let me go edit it manually. No, the AI has generated so much code, and it's so bad that it'll take you forever to get it, like, done manually from there. You know, it's way, way slower to edit AI gen code than it is to edit, like, well handwritten code, like good handwritten code. So you end up having to at least get it into roughly the right shape for you to be able to hand edit it. Like, I don't even know why this was even there. Also, all the kernel launch checks are gross. You don't CUDA check every line, my guy. My goal for this is roughly 10 files of roughly 1 to 2,000 lines each. Like, in my mind, the ideal structure is a relatively small number of relatively large files. I think there's an argument to be made for even just sticking everything in a file. We're not going to quite do that, but there's an argument for it. Jess, it literally doesn't matter what I say because it's not just idiocy, it's willful idiocy. Like, even if I come up with, like, a, hey, you know, experienced, been doing this for 20 years nearly. Shit, I actually almost have been doing this for 20 years. Like, even if I show, like, very clearly, they're gonna be like, oh, skill issue, you need to use sub-agents or whatever the fuck. Like, it's not worth it. I have better things to do than try to convince idiots. You know? Like, the point of what I do, this is not an education stream and it's not an entertainment stream. It ends up being a education stream some of the time, but this is primarily just we're going to advance the field. Like, this is just research done live. And I don't really need to just, like, be putting out content that takes my time for the sake of it. It's way, way more important to me right now that I am able to, like, get this into roughly the right shape in the quickest way possible so that we can continue to, like, build on our core methods. Because the self-play stuff, the reason I did this now is the self-play added so much shitty Python. It was just, all right, that's too much. I no longer have any idea what the hell's going on. And it's just, we can't just have this language barrier anymore. Yeah, Jess, it's very bad, honestly. Like, the most productive thing you can do is not try to fight it, not engage with it at all. Just ignore all of it and just, like, you know, learn real stuff, do good work. That's it. Because the progress we've had in just the last few months has been nuts. I mean, with 4.0, we're getting good progress on a number of different hard benchmarks internally now. 5.0, the main problem was we couldn't even find reasonably posed problems that needed an algorithmic change. And yeah, I stopped on it for a bit because we had to reprioritize a few things, but I mean, now we have essentially a good chunk of 5 and a good chunk of 6 already done. I can put up with that, Jess. It's just don't open the internet. It's easy. I'm looking for what else we can move. So this Puffer Vcache thing was just from a side project. I'll keep it there for now, but it'll be out eventually. These look like nice units. These, less so. Okay, so that's minus 50 lines. The funny thing, just as I thought we were going to have to do that, it literally does it for you. Like, Puffer just adjusts to the env speed. So if your env is slower, it just finds more data-efficient solutions. I think, honestly, the bigger thing with the hyperparameter sweep is actually just understanding a few of the hyperparameters that are often set unintuitively. Like the really low clip coefficients and stuff. There's some oddity there. Hello, Arch. Welcome. Okay, I like this file now. I like this file. I think I even like the loss file the way it is. Logging any config dashboard. This is just doing like manual hierarchical agglomerative clustering, basically. Hey, FBR. Breakout solve 10x infused end of stepping. What is 10x faster? What is this wall clock solve that you got? Because you don't have 10x overhead from the end. You can very easily get like plus 10 to 20% on breakout by porting it to the GPU, but there's really no point. It just like kind of complicates one of the simple demo ends. I'm just looking here at what we can merge. Oh, actually, this would be a good question. Sweep protein GP. I think it is worth it. CUDA port. Among other things, yes, Arch. So here we have proteins 1400 lines from the PR. And then GP is 784 lines. So it's over 2K lines. Mm-hmm. Buffer box is available. Yeah, I'll ask whenever you see Spencer. Speaking of which, I gotta make sure that I have, let me make sure that I'm not dropping his box. Still have money on this, it's fine. Yeah, of course, Jess. I I don't know, actually. I'll ask Spencer what he's doing with it at the moment. I think he's mostly... We're using the Vast box at the moment. If he's done with it, though, I also might want to let Finn use it for NetHack. I get the sense he feels bad about the Vast bill otherwise. And that's what the computer's for, right? It's for their experiments. Finn turn, yeah. Finn's been doing good stuff already. I don't know, I kind of just approached it as like, yeah, do whatever you want, learn some stuff. I mean, I'm sure that he's, like, all the stuff he's doing is going to be super useful. Hey, Valo. How's it going, man? I've been meaning to chat with you about the ends you've been working on for a while. Like, you have all this awesome stuff, and I just haven't gotten to looking at them in a while. Inferno plus Colo M's are going to be so nice. We actually really actively need, like, hard, but they have to be clean, right? Like, clean but hard test M's. Because we got to make sure everything works when I do this whole seaport. And then we're going to need tests for Puffer 5. Because I want to do something with state sets, but, like, if it doesn't help on hard M's, one, we have to figure out why, but I don't want to, like, just merge in new algorithm stuff that doesn't actually help. Like, we have enough of that bullshit in the field already. Still plateaued around wave 8. I mean... I would think Colo would be so much easier than Inferno. 3 mil up to 16, 17. Solved at 50 mil steps. You can get 50 mil steps solves. They're usually a bit slower, though, from what I've seen. 16 to 17 mil is good, especially if that's not on a top-end GPU. If you actually can tell me, like, what you changed specifically, you know, to integrate. Hmm. 3080 Ti. Okay, that is very good perf. I do need to know, like... I need, like, some actionable stuff, though, right? Like, I need a set of changes to implement that actually gave you speed with some measurements, not like, here's a massive diff from codecs or whatever, right? Polo's much more forgiving. Okay, for a bot, I guess you're somewhat right, Valo. I guess I didn't consider it that bad because it took me like a day and a half from just coming back to the game to get my quiver. Inferno felt much harder, but I probably used a very different strategy. Because I did it first, yeah. Well, you probably have a gear edge as well. I mean, I literally just brought Bulwark and Justy. I was like, all right. I will say, Valo, the one thing is, it probably doesn't know the start tile. Like, it probably doesn't know what tile to start on, and that's a major thing. How to start RL? Blogs on my, the articles on my X account. x.com/jsuarez. And just click my articles tab. Hey, Liberty. Been in CUDA for the last few months. Your GPU is full saturated. Yeah, I mean, there's a huge number of things that we can definitely do in Puffer. I haven't done like a big round of perf optimization in a while, but there's so much other stuff to do at the moment. Getting rid of Python in my mind is going to be so nice. Like all of our annoyances and user bugs and things, they all come from Python being a piece of crap. That seems really jank to me. I think that can just go to sweep. Double N. The one that's currently in Puffer, no idea. I think we use it for anything, right? Yeah, see, this is just a big mess. Happy 4th. Have you had some margaritas? One or two? Such a mess. See, like, this... Look what crept in. This is just so garbage. Keep in mind, I'm not attached to any of this at all, because this is all just... This is all just considered crap at the moment, this sweep file. This has not been cleaned at all yet. Ideally, bits of this will get glued closer to protein. Bits of it will get cleaned up. And it'll get close enough that I can start actually looking at what the hell's going on here. Like this stupid thing, right? This doesn't need to be here. None of this needs to be here. Like, why is it... Like, what on earth is it doing here, right? This is just bleh, bad. So if we can shave, like, a couple hundred lines off of sweeps between merging and just, like, unfucking this file, then that puts, I'd say, sweeps in a much better spot overall. There's way too much boilerplate and glue here. I don't even want to know what this is. Let's get rid of it. And then I think all of, like, the logging, dashboard, checkpoint, like, there are a lot of these little files that can probably get merged. That'll be next. We do have a few things that I'm not super happy with, like the fact that we have this separate kernel CU file. Like, I don't know why I did this. That's kind of weird. And then we also have a lot of these little things that kind of make sense as standalones. I don't like having all these little tiny files. I don't know, maybe that's just too pedantic, but... Or too... Not even pedantic, that's the wrong word. Like, this might be just too obsessive in some sense, but... Like, seeing all these little tiny, like, BF16 file that's only 40 lines, precision file that's 58 lines, that probably has this in it, right? Like, yeah. 100-line table files, 22-line puffer end file, 94-line... Like, just all these little tiny scattered bits annoy me. You know? Okay, this thing needs to go. We do have the old size, so this is 507 lines. We have size before and after. Okay, we don't care what test files it makes. We're not going to maintain any of those. It can just do whatever with that. We don't do those types of tests. We mostly do perf tests and then integration. Frankly, mostly just perf. Okay, it's hard coding all of this, which is really jank. Okay. It's shorter, but there's a mess. Why is this all... If I can find where this is. Interestingly, it's not in here. Where did it edit this from? Oh, okay, actually this is fine. That's just the test file. So this thing is still bad. This sweep crate here. This is not in here anywhere. Weird. What CUDA? Like 13, I think? 13 or 13.1? In newer versions, but changes are 13. How on earth are you using stuff that matters that much on the CUDA version? Like, base CUDA doesn't change that much, right? Version to version. It's mostly the libraries on it. Immediately refused. Yeah, Valo, I no longer give them money. I'm very happy to just help them speedrun bankruptcy any percent. Yeah, it's the most, like, it's the most out of touch company in existence. Least substantial one. They've literally been that way from day one as well. It's not like a surprise or anything. Notice that I dropped Claude like months before they did this, just like figuring like, I'm sick of giving these idiots money. Some stuff that only works on certain versions. Do you have an example? Like, I can't think of a single thing that you could have included that would have been version dependent. Yeah, this actually did make it a little tiny bit shorter. Not significantly, but we'll be able to do that next. What this is. Mess. Okay. That's not that bad. Puff config get. I would like to move this up, maybe. We have all this self-play stuff in leagues. It's annoying. And train work. I'm trying to think if we want to move validation up or not. Is it in config right now? Hmm. Puffer 5 is going to come out well before this year is over. It might end up getting switched so that most of what was planned for Puffer 6 is actually Puffer 5, and most of what was planned for Puffer 5 is Puffer 6. I don't know. The whole self-play thing has kind of thrown a wrench into this, frankly. Longer total train steps. Yeah, so crit, this is a big annoyance, is if you take a fixed config and just run it for longer, you can do worse because of the learning rate scheduler. I have not been able to get schedule free to work. If anybody wants like a reasonably complex, like, but well-contained research task, if you can actually get schedule free to work, and you have to have this tested on a bunch of ends to confirm it, but if you can get schedule free to work, it would be a very large contribution to Puffer for that reason. Like, we would like to be able to just run shit for longer and have it work. You guys see why I have this title as Mucking Through Sewage? Like, it's just such a mess. Like, the problem is that if you prototype stuff in Python first, like, you don't just port the Python to C and then be done. The structure that, like, the clean structure ends up being fundamentally different. Any ends you'd recommend to test things on working? Yeah. Puffer 4 would be the stable branch. I just tried something quickly and I didn't see anything work. Obviously match breakout speed run. We'd want to see at least like one of the longer running ends. Like, probably mazes are good, 2048. If I saw breakout mazes in 2048 all working, I'd merge it from that. You'd also obviously you'd want to test, like, you know, getting the sweep result that matches the current sweep result or is better, and then you run it for longer and it keeps improving or whatever. How did it just add 100 lines of code? Piece of shit. No, the base CUDA API is very, very minimal. I mean, that's more of a language than an API almost. I mean, I guess they change a few things here and there, but it's mostly the libraries that depend on CUDA. Like, their higher level stuff that changes a bunch. That's fun. Is that a scam or is that a real invite? Oh. That's cool. I will test that out. That's pretty nice. Isn't that the thing that Elon always wanted to do from back in the PayPal days, was to have a financial transactions app called X? We just bought Twitter and then added it to that and renamed it. That's funny. That's good. I don't think we have like a specific backwards compatibility target for CUDA as much as we have like well, probably that shouldn't break because we don't really use any of the more niche fancy things that change often anyways. It just added 100 lines of validation for absolutely no reason. Yeah, it's quite silly. I am actually very happy though that we're gonna get rid of the like the little bit of Python overhead on startup. This is dumb. Fuck is this? Noxious. Tiling. Wait, but like, if anything, wouldn't you just play with the Kublas settings? We don't have any, like, fancy operations that would need custom tiling. It's literally just map moles. At least in our default path. Still a mess. Okay, that's minus some, but we need to get, was it 580 it was before? This is still 40 lines of wrap up. Which part of Puffer is still Python? With this, nothing. In, before this port, in the current 4.0, there is, like, a launcher that also handles the multi-GPU wrapper, and config parsing, and command line args. A few other things that's in Python. And then protein is the big thing that was in Python. I mean, like, the dashboards in there's, like, lots of little things, right, that were in Python. This is going to be very nice, because you just won't even need to have Python at all. Hmm. No RL, okay. Still longer. Oh, wait, wrong file. Wait, is it? Uh, I think it was plus plus or whatever. I don't know for sure. Yeah, ballot same time. Hmm. Yeah, this is one of the actual like ones that makes some sense. It's cool. Getting there. Let's see. Shorter. Yeah, that's shorter. Okay, let's see what else there is in here. Huh? God damn. Thing just cannot help introducing garbage. Like, this is unfortunately still faster than me doing it manually, but hell is this dumb. Like, the last pass is, of course, gonna still end up having to be manual. But, Jesus, like, look at this, right? Trivially dupes dupes the hard-coded validation check. This isn't a CUDA bootcamp, Jess. This is like a not being retarded bootcamp. I mean, this is just like basic, keep it simple, don't abstract or duplicate. This has nothing, so the speed at which I can edit this has nothing to do with CUDA. This has more to do with the original structure in Python not mapping one-to-one with the C. And it mostly has to do with a huge amount of structural change all having to happen at once. Yikes, what? Oh, yeah. I was gonna say, usually people say, like, yikes when you drop a slur by mistake. Nah, okay, we good. I mean, once you really, and I mean once you really see the extent to which the whole overarching idea behind Python is just bad for stuff like this, it gets easier. It got 9 lines longer. I mean, obviously, like, a lot of this stuff is bad as well. But I mean, like, do you see what I say? I mean, when it's like roughly the right shape is what I say. It's like, yeah, these stupid helpers up here, this is like garbage. Right, but then look, we've got one big validation function. We've got one place where we parse the config into a struct. There's some questionable stuff here, but not that much of it. And that's it. And then we can look at sweep. Okay, there you go. Now it's actually the desired length. Good. Okay, so there's some weird... Yeah, this is very odd. This also... Yeah, we should just canonicalize this into, But that's, like, decent for now, at least. I mean, do you see sort of just, like, the give and take here, though? We should also... This should go into config. This, like, sweep runtime should go in. So that's one thing we can move. Unfortunately, there's still enough stuff in here that it seems unlikely we'll be able to remove this this entire file. That might be okay. The way that it did this is very bad. Good. 577. Okay, there's a lot more to do here, but sweep is now down to 410 lines. This is... This shit is guarded anyways, isn't it? Does it need to be guarded? Precision T. I think this is dated. That's funny as fuck. All right. Yeah, so this is stale. Good. So this gets cleaned up a little bit. Presumably we can merge some of this stuff. Actually, there's no reason this can't just go into kernels or something. Yeah, there you go. That's actually way easier. And then that would be minus 19 lines and minus a file, which would be really nice. We don't need 8 dims either for our tensors. We can probably reduce this to what we actually use. 4 or 5, something like that. Second, no longer need it? Looks like it doesn't. I think actually, yeah, we did make it so Vec no longer depends on this, right? That's why we originally had this mess. But yeah, Vec really doesn't need access to these tensors. It's quite simple to do without it. Okay, that's minus a file. And minus some code. Source BF16. We can include this, I believe, with the puffer env API. I'm intrin. Okay, this is sketchy. BF16. I don't think we use this actually, do we? Maybe we do. Nice. Because I think you do need it for that, and I think that's the only place you need it. I don't actually know whether this will be needed by, we might need this in our model or whatever. But probably not. I think that this is fine to just have here. And we're down to 13,531. And how many files here? $25 files. Nice. Let's build this real quick. This is on my slow local GPU. Nice, this looks good. What are we doing? We are refactoring this C and CUDA port of Puffer. I guess this is Puffer 4.5, maybe 5. Factor config plus sweep params. That's another 120 lines gone. Let me get this authenticated real quick. Whoops. Ignore that in the background. All right. Put some changes. Not remember some of the things I... Okay. Let me take a quick look. Let me take a quick look. Okay, that's pretty cool. Some floats can be converted to ints. The min group can be optimized to store values in registers, depending on how big the buffers are. You don't need to have separate sequential steps. Generate all M's in parallel. Wait. Cutting out with the CUDA port for breakout. Yeah, so obviously with the CUDA port for breakout. Yeah, you obviously you can cut out the copy. But wait, how on earth does that get you? Oh, because you had 47% time on eval? I see, because almost all the time was on eval. For your, I wonder what does mine... Oh, actually, yeah, mine would work exactly the same way as yours. But the thing is, I don't know if this is... I mean, if we just do, like... See, that gets you to 4 mil already. I wonder if it's single buffered is faster? No, it's not. Huh. I am honestly surprised there is that much overhead still, even on a low-end system. So yeah, with this setup, I guess it makes sense. Presumably the CPU was just getting hammered somehow. Even though the end should be, very fast. Do you remember how much you got off of Mingru? I frankly, I have no idea why the CPU gets hammered as hard as it does. It really shouldn't. It should be very lightweight on CPU. Can probably optimize that. Yeah, as in timings. I mean, you can also open a PR with it. Like, I won't merge the PR, obviously, if it just has a bunch of random stuff. But I might go, like, pick stuff out of it, you know? Morning. All right, let's see what we can do next here. NSYS. Yeah, NSYS is good. Actually, we have the, if you just grab the profile kernel script, the profile kernel script already is built for that. Like, you can run that with NSYS. Okay, let's see which of these files we can realistically think about merging, right? Like, we have too many of these stupid little files. Like, this shouldn't even exist, should it? Hmm. I mean, realistically, how many of these do I know for sure are good? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are actually only 10 files that I know that I'm happy exist in here. I don't know where the rest of the shit should go, though. I think these two together are fine. It's probably the interface on models that's screwy, frankly. There's just a whole bunch of random gross stuff. Oh, well, there it is. I think a lot of the logging stuff. We can merge eval with puffernet, maybe? And merge eval with puffernet. But this is a .c with a main file. We can still do it. Yeah, we can definitely get this to be merged cleanly. Okay. Well, that's annoying. It just goes on pufferlib. Okay, we can merge this in. That's -1, easy. And then we'll look again. Same number of lines. Oops. Huh? Okay, I don't know what the heck. Oh, and oops, I sent to the background process. So aside from merging in, I think that's fine, honestly. We just get rid of the dead stuff. I mean, dead code is fine. We'll try the eval CPU next. Puffernet. Hmm. Keeping Puffernet on its own is kind of nice, though. Pufferlib.cu, pufferlib.c, maybe. Tiny little file, though. If it's not obvious, the reason that I very strongly prefer having as few files as possible is you just get lost very, very easily when there are a ton of different files, unless it's like a very, very obvious standalone unit. Like, it's kind of fine to have a small file for Muon. It's kind of fine to have like a loss file, like a loss function just for this one big kernel. That's kind of fine. But when you start like breaking up structural stuff into lots of different files, it gets very easy to get lost. So that doesn't mean that like it's always better to have the fewest files possible, but it's kind of like lines of code. It's a very strong signal that you probably want less. Like, okay, hang on. Table, cache data, and constellation, I think, is going to be next. Nice. We'll have to figure out some other thing to do that's not the T-Snake for the third plot. But we'll probably make some nice changes to Constellation as well anyways. Um, yeah, I honestly, there's probably better stuff we can replace that with. Training curve viewer, maybe. Yep. So now we do have to still clean up cache data and the table code at the top of Constellation. But this is like very quickly getting to be smaller. So because we did all those other refactors before, now we get to cut some files down. And then we'll think about what else we can break up. Very nice. 1, 2, 3, 4. 21 files. I think we started with like 30. Nice for things to be live. It's not that like I can nix, it's just there's no reasonable way to do that at all, Jess. Yeah, 24. I mean, I could think about it, Jess, but like, yeah, there's because of the pre-processing and stuff we do, it's like a fundamentally batch operation. Ugh. I guess it would be nice to be able to like monitor a full sweep, huh? But the thing is, you'd still need all the data locally. Like most of the time you're going to be running it. So you'd have to be like pointing it at a remote server. That sounds like a lot of work for something that's going to be too inconvenient to use for most people. I will probably add like a single file thingy arch. What I'll probably do is I'll probably just add a wrapper that uploads all of your data from runs to Wannabe. Like just like literally takes all of the data and shoves it into Wannabe. There's not really a point in me trying to switch to GLM because there's not really any reasonable server of it at the moment. If Cerebrest could get like reasonable usage plans behind their stuff, it would be awesome. Without Python. No, it's all their whole stack is Python bullshit, man. Like, I'd be surprised if they have any code that isn't Python at this point. Or JavaScript, I guess. Blech. Okay. What else definitely needs to go? We have checkpoint.h, which is this tiny annoying thing. Selfplay.h, sweep.h. Merging it all into a utils is way worse. Vcache we can ignore. Python getting replaced. I'm sick of dealing with Python. It's the source of most of our bugs. It's the source of most of our performance issues and like users not being able to use Puffer. And it's also the reason why a lot of our stuff is like has to be poorly designed. Honestly, like the CUDA to C barrier is already bad enough, the way that most people write CUDA and C. You definitely don't want multiple language barriers, and in fact, even different compilation units is bad. Not until PyTorch is superseded. You realize we don't use PyTorch here, right? Like we have our own trainer that is 4 to 5 times faster than Torch, and way more numerically stable as well. That was kind of the whole deal with Puffer 4. It's only about 4,000 lines of code, and it does everything that we need. It has multi-GPU, has integration with all of our other stuff, and it could be cleaner, but it's a heck of a lot more readable than the PyTorch source already, I'll tell you that much. Current PC setup? I have a mini ITX box that I built many years ago with a 3080 that is somehow still alive. And I'm just using this for now while I'm here. I have a better setup in my main office and on the farm. We just have a whole bunch of random... It's just a bunch of, like, random file I/O and crap, I think, right? Has all the kernels. Here. We have... This is our mingru. We have our mingru kernels here. This is your inference path for mingru. It's very simple. Prefix scan's a little more complicated to do fast for training. This is why I say it's not as clean as it could be. There's this annoying recomputation thing. Here's your backwards pass for mingru. Again, a bit more complicated than I would like, but not terrible. We have all sorts of very nice things in this setup, though. We have, like, contiguous memory weights, contiguous memory gradients, single kernel to apply model updates. I'm not a big fan of this stupid thing that we have here with all these init functions and things. I think we can do much better than this garbage, like pseudo polymorphism bullshit. But I mean, for what it is, it's pretty damn good already. And it is genuinely, like, much more numerically stable as well. B-Float 16 training works perfectly every time. Watching US game tonight? Nah, I'm not really, I don't really watch sports. The sports that I do myself are incredibly boring to watch, so... That why you're so locked in? Not really. I mean, literally, this is my second monitor at the moment. This is not, like, super... This is mostly just, like, kind of thoughtful work. I just have to figure out how I want this to be structured for a couple of days. This is already a big improvement, but there's still, like... I'm trying to figure out how we get this down to more compact. It's like the puzzle pieces don't fit together perfectly. Kernel timings in Discord, thank you very much. Oh, really? Shared mem backward. Cast fusion plus shared mem. So I'm assuming that that cast operation, that's not a CPU operation. That's just like you fusing the... That's you fusing the GPU buffers for GPU ends would be my assumption. But then you do genuinely seem to get quite a bit from shared mem backward. That's actually a very useful thing to know. I do wonder if that makes, if that change does anything on the main hardware target. Yeah, I would like to read a PR for that. Maybe not this second, but if you put a PR up for that, I will at some point go through it, because that is, like, that is the most important operation in the pipeline, is, optimize min-grew. All right, so, I mean, we have, like, some of these things that are kind of standalone, but not really. Like, we got this config loader. We got this dashboard. I guess self-play and sweeps are kind of awkward, right? Maybe we can bleed some of the big inlined kernels. Can we bleed some of this from Puffer into, like, kernels here? And then bleed the launcher stuff into this? Does that make sense? Stop learning to code anything. Those people are idiots. Just mute them and move on. Stop reading code. Yeah, you should... Yeah, you should just mute those people. What do we have in London Puffer? And also, there's one other thing I want to check. Device. Okay, we have a couple random bullshit things. Okay, we can actually drain. That is going to end up being another... Cast Fusion in parallel. Limited by trans. Using map mole timing. Interesting. And those are good optimizations, man. If you can get the things cleaned up into, like, testable, mergeable things, like, yeah, by all means. I do expect that the CPU path can get optimized quite a bit, because I refuse to believe that we're bottlenecking on simulating breakout. So there's probably, like, some, like, just poorly done copy path somewhere. What's it need? It shouldn't need shit from loss. Puffer.py gonna be refactored. Yeah, that's already done, Arch. Well, at least a draft of it's done. It's crap. So this is what I wanted to figure out. So first of all, did it make this longer? I'm assuming that it just didn't finish deleting stuff. Where's advantage? 379 lines. Okay, that's a decent chunk. I think some of the optimizations in there were premature. This was like early stuff with Jonas. Or Jonah. single set of weights on all. So you can't do that because the obs and action spaces don't match. That's the key problem. If you came up with like a reasonable way to train in encoding, then sure. It's pretty obnoxious though. Is the naive way? Yeah. The thing is, like, it doesn't really matter that much in some sense. You kind of just don't need to train big general models when you can sim really fast. CUDA occupancy max? What is that? FPR, that's fine. You, like... I'm pretty sure that CUDA's it's only deterministic based on the GPU and the CUDA version anyways. So I don't think that that weakens our determinism guarantee. My guess would be that the issue that you had there is not that you screwed up the learning, but if this is on your swept parameters, there's a reason that we don't use like 50 mil. So you can get parameters that solve in 50 mil, but only subject to seed. So you need to run it for a little bit longer to make sure that you're getting consistent solves across seeds. If you try that, I think you'll see it works. If it doesn't, something's incredibly sketchy. Yeah. Just don't break our determinism is the main thing. Like, that's one of our best features. And it's really obnoxious to tell when you've broken it. I mean, I'm sure I'm going to end up breaking it myself doing all this jank. But at least I will be able to fix it. So we just have massive logic kernel. Simple logics. I guess this is... Yeah, this is inference path, huh? Okay, this policy build crap is obnoxious. We do have... I think we have a bunch of redundancy in here. This is dumb. Hello, welcome. I'm not seeing anything other than the Logit stuff, maybe. Okay, there's a whole bunch of loading. If I figure out a better way to do policy... Do we consider cosine annealing part of the optimizer? I mean, that would be a good spot to stick it, to be fair. The only big block of crap I see in here is logits. Yeah, I see logits mainly. There would. Oh. I think that's an option. That's not going to save us, like, it's just moving this tiny little bit of code and also deleting this standard library usage. Did we just get less code? Oh, yay. Wait, no, 331? Oh yeah, 30 lines minus, okay. And self-play, 833. Okay, so just minus a little bit from this. I don't have a good spot to stick sample logits if I move that. I'm not sure I want to yet either. The pressure from self-play is annoying. I mean, that was originally the reason we did all of this. Here, I think we'll get some ideas real quick. Self-play team. I'll take a look in a second. I'm just thinking. It's sort of tricky. Because the thing is, it's like, it's tied into everything, right? It's this thing that's very important, but it's only used for a small fraction of the environments. And it's just tied into everything. Here, let's do this. Okay, look at this. So, 4,000 lines of Python. All right? And just the bits, like this is 400, this is 800. This is plus 1,200 lines of Python, plus there's some stuff in here. So let's say plus 1,500 lines of Python for just self-play. Doesn't that seem like ridiculously excessive? Porting CUDA in between the running test. The thing is, man, like, just porting env to CUDA on its own, like, just randomly is not super useful. I guess on lower end hardware with your changes, it makes stuff much faster. But I'm guessing that also there are probably just some CPU side optimizations we haven't done that would bridge a lot of that gap. And probably like the generic min group change is going to be the most useful. Obviously, for envs that do use GPU, we should use that GPU optimization. The thing is, like, it's not like every env should just go to GPU, right? It's going to end up being very specific physics heavy or compute heavy envs where you cannot reasonably get above 1,000,000 steps per core per second on CPU. Yeah, no, I know it's basically the same. I mean, most of the time you just change the you just change the method to device, and then you change the math functions from the C library to the CUDA library. Taste for architecture? That's not taste, that's just being bad. Yeah. Whoever came up with that, it's like a genius marketing thing because it makes it seem like, oh, it's just they're bad at the subjective parts, but it's really not that, right? It's not that it's like just because the tasks are hard to measure doesn't mean that they're completely subjective. Like the correct words are like bad, stupid, dumb, useless. Not just, oh, they have poor taste. Right? Like the latter, it just sounds like, oh yeah, they're gonna fix that. That's just a minor alignment issue. It's not. It's a huge skill issue. Mm-hmm. Yeah, so I think that the big problem in my mind is that you have this self-play code, which really is only used for a small chunk of ends. It's very important, but it's not going to be used everywhere, and it's cluttering everything, and there's not really a reasonable way to separate it. The only thing we can do is kind of group it better. Okay, first of all, the code is just crap. Self-play. Oh, I'm sure it did, Jess. We don't have, we have not ever had this in C, though. Like, there was some stuff you're doing, for instance, with checkpointing, where we have the checkpointing already in this, in the CUDA optimized. And, you know, you have access to it now because there's no longer the barrier between languages where you can't just easily call everything. Mm. What am I doing? Welcome. I'm working on the highest performance reinforcement learning library. Um, Currently that involves wading through a whole bunch of AI gen bullshit and trying to get it into a state that is remotely acceptable. We had a bunch of stuff in Python that we got to get rid of all the Python. It's just bad at this point. We're trying to get everything into CUDA C. It's way too much code, and I'm trying to like pare it down a little bit at the moment. So technically, yes. If we keep all of the paths around, then we no longer need to do any of this IO loading stuff. We could extend that into the sweep architecture as well. Any extra paths could be dealt with. What's the end goal? Well, the end goal is to take the field of reinforcement learning as a whole, which has been sort of stagnated for years, at least before Puffer, make the thing about 10,000 times faster, which for the most part we have done, make some major innovations on the architecture and algorithm, which we've done, but there's still quite a bit left to go, and simplify it dramatically such that it's relatively easy to apply to new problems, which we've made a lot of progress on, but there's still some room to go. So at this stage, I think it's mostly we need better performance for our current algorithm. We need a much cleaner code path than we have at the moment. And then there's maybe a few last research questions that we need to answer before we can start reliably chucking this on like really hard unsolved problems and just having it solve out of the box. We're at the point we're pretty much within like a few days of like semi-skilled work, you can set state of the art on most RL problems out there. Even ones that have had concerted effort behind them. But there's still a few issues overall. Yeah, this is RL not for language models. We train tiny superhuman models. A lot of our research tasks are games. Turns out games are a really good task for research, but they can do much more than that. Games are just nice and interpretable, so they're good benchmarks. It's pretty unintuitive what tasks are challenging or not in RL, frankly, if you're not used to it. I don't see any reason that we need to checkpoint more frequently than the snapshot interval. Is there anything else we can save with this? I think that's fine to start. RL environments that train agents on specialized tasks. Wait, what do you mean RL environments that train agents on specialized tasks? If that's for LLM stuff, I have no idea. But like, that's kind of the entirety of what we do here is we train RL agents on specialized tasks. So our goal is not to improve general capabilities, it is to solve the specialized tasks. Yeah, but that was kind of like just train on a bunch of really complicated tasks, Jess. There's still definitely merit to it. I mean, what would it look like? So it's kind of difficult to... The thing is, it might be kind of difficult to imagine how the hell you scale RL up to general intelligence like that. But it's also really difficult to imagine how the hell you scale intelligence up from GPT-1, right? Like, people can say, oh yeah, this will scale, but nobody fucking saw it. They hoped, and they happened to be right for, like, a decent chunk of their assumptions. But there was just no reasonable way to predict the extent to which stuff would scale. Similarly, with RL, like, what would have happened if we had gotten... I mean, what would even be reasonable? Trillion step per second training? I think that's actually pretty reasonable with small-ish policies on 1,000 GPUs. Yeah, so what if you got trillion step per second training on, like, a full-scale... Like, think of, like, the most ambitious game-type project ever, but it's essentially just meant to have tons and tons and tons of different stuff to do, not, like, designed for people, necessarily. Just, like, the biggest virtual world project ever. I mean, what's the most that's ever been spent on an MMO? I think it's like most big game dev budgets are in the hundreds of millions of dollars. All right, so the labs have spent tens to hundreds of billions at this point. So what would happen if you just tossed $5 billion at development of, and I don't even think you'd need that much, but what if you tossed $5 billion at the development of a really big virtual world? And you made it super fast, used like 90s style game dev techniques, and you scale training to a trillion steps per second. Dwarf Fortress would be very cool. I have no idea how fast that env is. It's got the same problem of NetHack where the obs and action spaces are a pain. Get the guy Roller Coaster Tycoon. I don't think we would quite go to like write stuff in assembly. More like very minimal game engine in C using 90s MMO development principles. So the whole thing would probably be on a tile grid of some sort. Or at the very least, it would like just be animation smoothing and making very coarse movements. The interaction code is very simple. Yeah, I have no idea why that guy did it that way. He probably just did it that way because he could. That is his cited reason. That's funny. Why you do it? Oh, because I could. Vision models needing a certain size is just sad. No. Yeah. Um, to be fair, like domain-specific vision models probably can just be a few million parameters. We have decent-ish stuff like with just a few convs, but at our current scale, that like cuts perf by a factor of 10. So it's just not super worth it. If anybody wants to try to get like a decent vision encoder just as fast as possible, by all means, go ahead. I mean, that would be an amazing contribution to Puffer, but I think that it's probably just going to hard bottleneck by a factor of 10. Just like straight up based on the number of bytes in the input. I guess you could get maybe like a 64 by 64 render. Even that is rough. And that just doesn't give you a lot of information. I mean, you can kind of just do the napkin math of the amount of data that goes through the system with like 128 by 128 images at 10 mil SPS. It's a lot. Okay, that's like false. Reasoning, how we do observation. Pretty much. Switching out obs. Well, I mean that's just I mean that's not that's just encoder, dude. Like, yeah, what is the minimal encoder representation for different data formats is the precise form of that. Decent compression algo. Uh, sketchy. I mean, if it's a frozen encoder, potentially. It would help if it were a frozen encoder, to be fair. Oops. Maybe, Jess. I think that'll just become more obvious as we solve more hard ends, though. Like, we're actually not... Like, pixels are not my top concern, even. Solving pixels solves maybe, like, 20% of the obs issue. Right, so the problem with looking at vision as compression in that way, right, is we actually don't care about representing the entire... We don't care about the full representation of the image, right? We only care about extracting the portions that are useful for behavior. So that's why arguably a compression objective is not ideal for RL. Compression objectives force you to much larger models than are required for policies. It's a subtle point, but an important one. Right. Okay, so... Yeah, it's one of the reasons that RL policies get to be so small. There's just a lot of stuff they don't have to care about modeling. Okay, this looks like a miserable way to spend the next hour. What do you all think? Yeah, that looks pretty miserable. I guess it would be this plus... What is it? It'd be this plus this, which is even worse. Hmm. Well, let's see if there's anything else that we can work on first. So we know we have to tackle this whole self-play sweep mess. Probably it's going to result in shortening a whole bunch of this code, merging some of this into there, and then some of it into Puffer. What other files definitely need to die? Or do we convince ourselves that, No, we don't convince ourselves that all these files are fine. There are definitely at least a few of these we don't need. I think that is the best way to spend our time, though. Whatever. I like suffering. We will suffer a little bit. But I deserve a couple minute break here. Let me get up, use the restroom, walk around a little bit, grab a drink, and then I will be right back. And we will work on this, alright? In a few. Oh yeah, start Puffer on GitHub if you haven't already. It helps me out a lot. All right. Hang on a second here. Ay, ay, ay. I see. So this is useless. I think I remember that being a stupid thing that got by. Which frozen checkpoint each bank is using? Wait. Lovely. See, this is just a thing that apparently Codex randomly did and got by me. It's completely fucking wrong, completely and utterly stupid. Fucking LLMs, man. How much does that remove? 90 lines? I think we can get rid of more. Self-play bank. Do we still use this historical win rate thing? Mhm. What about this max pool size? That seems kind of weird, doesn't it? I'm streaming another 45 minutes as well today. Seems reasonable. Little short, little 4 hour stream. This type of work is very obnoxious. I really don't have I mean, I did a couple hours of it before stream this morning, and about 6 hours of this in a day is the most I can handle. Otherwise, like that is my my tolerance for bullshit, let's say. Vision observations into puffer. Um well, the end game for good vision observations would be that a client really wants them. So we put the effort in to come up with a relatively efficient policy that doesn't completely bottleneck training. We get vision to like, I don't know, 1,000,000 steps per second on a reasonable model size, and then we scale it. Probably something like that. Well, because like there's very little research on making anything insanely fast. Basically any individual component of puffer on its own doesn't do anything for the field. Like if we just took our trainer, for instance, or like our model architecture, whatever, and we plug it into any other RL library, their stuff will bottleneck it so hard that you'll see zero advantage from any of our improvements. That's why we had to redo everything. Whole stack. Yeah, I know that there are like production vision things where they would be very happy to get 1 image per second. It's kind of sad. Interesting. What would we log for self-play then? Ist n. Do that. $1.6 mil. I could believe that. With like not a crazy policy arch. That would still be pretty good though, Casper. Actually, if you were well, I guess one project, if you were interested in doing it, would be you could take the ProcGen environment, which has they have like all this dated Python code that barely runs anymore, but the source is C++, so you could probably just port or auto port even ProcGen. Change the texture pack to get 64 by 64 obs and get it into Puffer at like over a mil SPS. That would actually be very nice to have ProcGen at reasonable speeds. That'd be pretty cool. I think at those speeds with a proper per env hyperparam sweep, you just full solve instantly. We do have a Kudian N bind for cons. It just wasn't that fast. Kudian N is also kind of jank in the way it works. Buffer quality. We are less strict on environment bindings, Casper. Yeah, we're less strict on environment bindings, as long as they're correct. It's mostly the puffer core code that we're super strict about. So you could probably just stick all that into the bindings. Huh. Jesus. Make some login. Like the crafter, craft axe, nethack binds, all the RuneScape stuff. It's a lot of it is like AI crap, at least by people who have some idea what they're doing and aren't just like noobs vibe coding stuff, but are just very heavily. They're at least like giving reasonable instructions at a systems level rather than a feature level. Um, Obviously not good for core. You see me doing that with core here, but then taking literal weeks to edit stuff manually and get everything clean. But the end of binding, since they're purely horizontal, right, and like end of binding being bad doesn't screw up puffer core at all, we're less strict on it. Pirate software type code. I never actually watched any of that guy's stuff. I don't know if his stuff was good or not or bad. I don't know. Actually, funny enough, I watched some of Primogen's stuff when I was first doing systems. He has some good takes on stuff. He just gets nerd sniped by every new shiny thing. But he's kind of made himself a job out of just doing that on repeat now, hasn't he? Infinite magic numbers. So fun thing. I don't think that that is bad. If you're hard coding constants that are only used once and just like not splitting stuff up and doing it top to bottom, that's actually totally fine. If you look up, I'm actually happy with this code. This is Neural MMO 3. It's 3,000 lines. It's all in one file. This is the core step function. I guarantee you, if you tried to like split this up and whatever, you'd end up making it way longer. Yeah, procedural is just good. It's really simple to do this as well. It should almost be default. It's like you make a new function when you would have to copy paste code otherwise. You don't make a new function just to make a new function. You default to write it top to bottom. You default to use the simplest data structure possible to accomplish your task, right? Minus 60 lines. So we're minus 1,000 lines of code today for the same features, or same meaningful features. Minus 1,000 lines of code in a day is not bad. Do we need... We probably do need the evict thing on self-play, huh? Do we need the wait file thing? Well, I mean, I'm not even gonna bother. See, but Crass, the thing is, like, doing stuff in the shortest, simplest way possible, that is the nice thing. All the, like, oh, I want to come up with pretty abstractions that scale, that's just Google Nerd Snipe bullshit. Like, for the most part, you don't make nice building blocks for other people to use. Because their blocks aren't the same shape as yours. Oh, that's just straight troll. Yeah, the functional people are just straight troll. You have to at least drop the immutable memory bullshit before you can even have a conversation about other stuff from there. Sometimes the most maintainable thing is this is short and easy to rewrite if the requirements change. Like the highly abstracted thing is almost always harder to rewrite if you guess wrong. One guy started adding errors as types. Jesus. The whole error handling thing is also incredibly dumb. Like, for most applications, um, like, when an error is, this should never happen and there's no way to continue if it does, you don't want to pass it back up the stack. Like, you want it to just, the code to die and print a stack trace right there. Really simple stuff, and you'd be surprised how much code that saves. Oh, it still adds fallbacks for everything. You have to yell at it to get it to not do that. One of the funniest things, in my opinion, is like people say Google's core advantage is, oh, they have all of their own code to train the AI on. It's like, are you sure you want to train your AI on that? Really? I don't know about that one. Some of my code. Heh. At least the pieces that I've actually been able to put some time into are good. All right, what we got here? Oh, perfect. Minus another 30. If they have high quality code, that's the joke, Crit. They kind of don't. I'm sure they're like 5 guys that don't ever leave their like basement office at Google that actually write all the good stuff. But the average dev is like, yikes. None of the big tech companies have like good devs on average. Not a single damn one of them. It's kind of one of the unfortunate things, like honestly, about like actually giving a shit about the quality of your work. You basically can't work at any of the big tech companies, at least not unless you're going to a specific high talent team, because you'll just be miserable. Just the quality of stuff is awful. See, the thing is, the hiring bar is like, it's completely decorrelated from actually knowing what you're doing. It's not a high bar, right? In the sense, it's not like you have to be a good programmer. It's you have to have spent a lot of your time studying really dumb and arbitrary puzzles that have nothing to do with your day to day or like writing good code or building good systems or like anything at all. It's just stupid lead code. Have to pay you to work full time on improving Microsoft Teams for a year. Jesus Christ, man. How much does Teams make? It would have to be at least like 50 mil. I don't even fucking know. It would basically have to be like, all right, I got enough puffer funding to do whatever I want for a decade. Because, yeah, presumably, since it would go into a business investment, it wouldn't just immediately get hit by personal income tax. I'm pretty sure that's how that works. So, would yeah, 50 mil in funding would be plenty for all the stuff I'd want to do. Okay. 13105. Okay. 439 lines. This, I would believe, needs to be a few hundred lines. Gross. I don't even know what this does. This is just... What? This is just while true, isn't it? Actually, I don't even know why. I didn't even think this was valid. Oh, actually, wait, doesn't this... I think this does show up in, like, KNR, doesn't it? I don't even know what that does. I'm assuming that's while true. For nothing. 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 Like... I don't even... The fuck. Okay. And we'll have like 10 minutes to actually look and see if there's anything I can see to fix. Don't really need the anchor thing. Fuel. Okay. Yeah. All right, let's see what we have. Let's see, 15 minutes to get under 13K lines. What do y'all think? Does it need to compile? What? Yes, it needs to compile, of course. We need to be able to train breakout under 13K, while having not totally broken everything. Hey, bet. Client work's going well. Actually, the need for self-play is what triggered the early refactors here. Yeah, there's definitely stuff we can get here. DMs wanting a code review. Oh, is this the explosion, like the chain reaction env? It looked cool. We'll get to it shortly. Not today, of course. Today, I've spent 6 hours refactoring this mess, hence the title. That help? Barely. I see. So we have... Okay, actually the thing at the bottom is sort of fine. I think this is totally redundant. Well, wait, you should do the obvious thing to include, right? If you don't want to have to deal with full self play, is train versus the scripted bot. Duh, right? Upperlip acquired. What? If any acquisition offer for Puffer? No, and we're not really looking to get it acquired either. That's not the intent here. Like Pufferlib, first of all, Pufferlib is the open source library. If anything, we would be spinning out application companies on different problems we can solve with RL, and then trying to get those subsidiaries acquired. Like all our core stuff's just free open source software, and in fact, the company is specifically structured to make it easier to like keep doing all the open source stuff. We also there's like again making that core company public. Even if we could do that, that sounds horrible. Why would we do that? I have no idea what the hell that mess even is, Bet. Like, I have no idea who the hell's using that crap. 300 lines here. So also this thing is highly redundant, I would think, as well. I mean, we're not going to get today to, like, mess with this full thing. I just want to cut 50 lines and call it a day. Get it under 13K. Wait, why does it need to write for this? Oh, the score, sure. Ugh, 100 players? The fuck? Bit by bit, all the code just disappears. It's kind of funny. Why do you want proc gen? Is it a specific thing or is it nice to have? Um, so proc gen is historically one of the better ENVs released. Like Atari and proc gen are the two that would be nice. I think Atari does have a RAM version. Possibly proc gen has a RAM version as well. I don't know. I actually don't know how they do it. You could probably expose the RAM though, or like some obs from it. It's a nice suite of ENVs, and we kind of don't have any reasonable third-party ENVs that we can compare against anybody else's stuff because everybody else's ENVs are so slow. So it would be good to have them, and it's like you bind one set of you do one binding and you get access to 16 ENVs. Is pretty good. Pufferlib in the RL second place. I knew there was like a sixth place or something. The second place also got it. That's cool. That's very cool. Mm, 52. Is that okay? We did cut a little bit. I think we'll end there for today. There's no point in just trying to get it under 26, 26 more lines today. I will push this though, as long as breakout works. We'll do a quick count of some stuff as well. Do you want ported to C or bindings with the C++? If it's much easier to leave the C++, you can leave the C++ if it's easier to bind, as long as it's fast. I suspect that, like, the per end code is pretty simple, though. Like, I'd be surprised if you couldn't just auto-port everything and just, like, confirm that the same actions produce the same result. I mean, I guess it also depends on whether the original C++ code is good or not. I haven't read it. If the original C++ code is actually good, then, like, yeah, just leave that instead of putting some, like, shitty code export. All right. So check this out. This is the current version. We started with, like, 10 more files than this and 1.2k lines more code than this. So we've cut quite a bit today. I think if we're gonna, like, let's be fair about how we were tabulating this. So I'm gonna say there's 1.5k lines that were from self-play. There's some in here as well. So 1.5k lines from self-play. 1.5k from Constellation, so that's 3,000 lines. This is nothing, so this is 1,700. So that's what's 4,700, 5,500. Anything else? 5,700. Did I do that right? It's at least 5,700 lines of this, though, right? So then that takes us down, if we're, like, doing the equivalents, this is, like, 7-ish K. Oh, no, but there's also... Hang on. We gotta do this properly. So let's add this up. So this is 1,400, so this is 1,700. 2K, 2.7K, 3.7K. Yeah, it's like 5,500 lines or something. So we're only at like 7K-ish lines here. It's not terrible. Over the original, I mean. There's still definitely some we can cut. But, like, at the very least, like, Constellation and Protein and stuff, we shouldn't count in that. Alright. We still want to cut, like, another 1,000 or 2,000 lines, I'd say, to have this clean before the release. And a few files. I'm tired. This was a short day, but this type of work is just incredibly, like, obnoxious. I can only really do this for so many hours, so... We do make progress, though. This is good progress on release. Thank you, folks, for tuning in. I will be streaming more of this, so if you're new around here, Hover.ai, it's all open source. Click the fish, or actually don't click the fish, he's not a link. Click the star here, star GitHub. Helps a lot. You can join us on Discord to get involved with dev. You can follow me on X for more RL content.